Okay. Hello, Yunze. Thank you for joining us today. You're always our one and only attendance.
Okay. Glad to hear. Not like for attendance, but
You're number one on the list right now.
Thank you for the support. Thank you for the support. Okay. So we're gonna do two problems today.
Really fast, and then um, depending on how much time. Oh wait, actually, okay. Let me just go over the concept first, and then we'll see. So for this one, we want to use a stack, right? And then I guess some things to notice is that let's say we have a stack, and then we put an element on, and we only want to take it off after we've found out that that we've like figured out like how many days it is until we see an increase in temperature. So basically, we put things on a stack and we take them off when we've reached that day where the temperature is greater than this. And when we do that, we also want to calculate how many days it's been. So you can imagine some kind of pointer or way we can keep track of what day we're on. And we want to iterate through our temperature list. And I asked you guys to find like a solution of end time. So hopefully like that's like kind of intuitive that like no matter what we do, okay, we're probably gonna have to iterate through temperatures at least once, right? So in terms of like a stack, this would be like put a temperature on the stack after we see it and remove it after we're like, okay, we've reached a day where the temperature's biggest. So let's say we have a pointer on day 73. I mean, the day where the temperature is 73. Okay, well, there's nothing on the stack yet, so we have no choice but to put 73 on the stack. And then we reach day 74. We're like, oh, okay, well, 74 is a temperature that's bigger than 73. So what we can do is you can take 73 off of the stack and say, okay, how many days has it been from this temperature since to like the current day we're on? It's only been a day, so that's where that one comes from, right? And then we're like, okay, let's add 74 onto the stack now, and let's move the day to the next day. 75 is greater than what's currently on our stack, 74, and it's only been one day since that, so we put the one on here. And then we add 75 to the stack and pop 74 off. And we can move on to the next day. Well, for the next day, it's 71, but 71 isn't a temperature that's greater than 75. And because of that, we want to keep 75 on the stack and then just add 71 and move on to the next day. Well, 69 isn't greater than 71 either. And then remember that for stacks, like the idea behind the stack is that the last in is the first out. So you kind of want to imagine like, oh, we only have access to the element on top of the stack, which is 71, right? And we're like, okay, well, 69 isn't greater than that, so we can't really do anything. We can't take 71 off of the stack yet. So we just add 69. And then if you notice that, like, because the only reason we would take something off of the stack is if we find a temperature that's like greater than like the one like before it, basically, right? But because of that condition, our stack will always be in decreasing numerical order. So that's why like when I'm comparing like 69, I only have to really compare it to 71 because I know that everything else before 71 has to be like greater than, yeah, everything before 71 has to be greater than it to be on the stack. Because if something was less than 71, then it would have been taken off of the stack because 71 would have been greater than that. Hopefully that like logic makes sense. And that's why we only really need to check like what's on top of the stack. So in our example, we move on to the day with 72. And we're like, okay, well, 72 is greater than 69, and it's only been one day since then. So that's where this one comes from. And we can take 69 off of the stack. 72 is also greater than the temperature 71, but it's been, oh, sorry. This one right here should have been this one right there. is greater than 71. It's been 2 days since that day because we're like on this day right here. It's been 2 days. So we put a 2 right here. And we take it off. And then we look at what's on top of our stack is 75. Well, 72 isn't greater than 75. So we end that and we put 72 on there. Moving on to 76. 76 is greater than 72, and it's been 1 day since that. We pop off 72, we add 1, and 76 is greater than 75, which is on our stack, and it's been 4 days since then. And then we put 76 on, and 73 is not greater than 76, so hopefully it makes sense why the last two are 0. All right, so hopefully this like logic and like iteration through it makes sense. And if it does, the code should come pretty naturally, I think. Did this make sense to everyone? You can unmute or type in chat, and I would be happy to like re-explain the stuff behind like the concept of the solution to this problem.
Yeah, that makes sense.
Wait, Anna, sorry,
Okay.
could you go over like how to keep track of like the output?
How to keep track of the output?
Yeah, or like how does that work? Yeah, like how do you populate
Like
the
how to
numbers?
calculate this?
Yeah.
Okay. Well, if you like notice, like we're kind of like counting the days between the date we're on with the previous dates of like the current the previous dates of like anything that's like on our stack, right?
Yeah.
And an easy way we can keep track of that is the index, right? So you can imagine like in code, when we pop something off of the stack, we would get that element, like let's say 75. And for 75, we were on this date. So 0, 1, 2, 3, 4, 5, 6. So on I guess day 7 or index 6, the temperature is 76, and then let's say we're at the point where we compare it with 75. We're like, okay, let's pop it off. Well, it can be like 75 is on day 2, and then 6 minus 2 is 4, right? That's where the 4 comes from. It's been 4 days after, or like 4 time steps after. So for this problem, in order to solve it, use like in code, you need to keep track of both the index and the temperatures.
Mm. Okay,
Does
wait.
that make sense?
Yeah, thank you, thank you. I didn't know. Yeah, I was just curious how we kept track of the index. Thank you so much.
Mm-hmm. Did you guys like end up finishing writing the code? Because we do have like some time, and I think it'll only take me probably like 5 minutes to go over the code. Do you guys want more time to finish coding up a solution if you didn't have time to, or would you just want to see the code? It's up to you.
I think I'd like to see the code because I've been coming up with the same like similar conceptual solution to this, but
Uh-huh.
now I'm just like confused about how to really implement this into code. So I think
Yeah,
that's
yeah. And then for this one, I'm like a big fan of utilizing like things in the Python library.
yeah.
And for like keeping track of index, there's like a enumerate thing. So I can just show you guys the code then. Okay.
Yeah.
Mm-hmm. I joined on my computer. I just heard mommy. Okay. Hopefully I'm screen sharing. I'm just gonna assume I'm screen sharing, and I'll switch tabs. Can you guys see LeetCode?
Yeah.
Okay, sorry. Yeah. So for this problem, like when I was drawing the picture, I like kind of drew a stack, so it kind of makes sense to have a stack. And like I mentioned before, it would really be nice to have like the index on the stack as well as the temperature. So those are the two things we want on the stack. So you can imagine the stack is like a list of like tuples, or you could have like a list of lists or whatever you want. And then I'm gonna have like an output array as well. And this is gonna be our list of ints, right? And then I know at the end I'm gonna return output. It's gonna be populated. So for all of n, we want to go through each of the temperatures and temperature, right? And then that function I mentioned is called enumerate. And what enumerate does is that it's basically like a for loop. So you can imagine like it's like what I typed in the beginning, like this shit, but it's also this shit in one. So like it basically does this at the same time. So it will iterate through every single temperature element in temperature, so like every single element in the list. But what it will also do is it will keep track of index. It will return that in a tuple. So what we can do is we can have two variables to catch that. One of them will catch the temperature, the other one will catch the index, which is kind of like the day that we're on, like day 0, day 1, day 2. You can imagine it like that. So let's consider like the complicated case where we're like on an element, right? And then we want to compare it with whatever is on the top of our stack. And we want to see, oh, is the element or like the temperature that we're currently on, is that greater than what's on top of the stack, right? And then if so if current temp is greater than what's on stack, then what do we want to do, right? We want to pop the element off of the stack because we're done with it. We have like all the information to calculate the output, because the output's just like, oh, how many days until the first day with the temperature that's higher, right? And then we want to add to output lists, okay, right? And then otherwise what we want to do, and at the end of doing this, like regardless if we do this or not, we always want to add our current temperature and our current index onto our stack. So hopefully that part is like more intuitive, right? So we just want to append that current index and that current temperature. Okay, so then there's also like the case, like in the example I went over, sometimes we would pop like multiple things off of the stack at the same time, right? And the reason why we do that is that if we have like multiple things like on our stack, like in my example, or like in this example over here, we have like 75, 71, and 69 on the stack, right? And then we're on this element 72. If we have multiple things on the stack, we will need to pop off 69 and 71. But when do we stop popping things off? Well, we stop popping things off once we reach an element on the stack where the temperature that we're currently on, which is 72, is not greater than that. So that was 75, right? Okay, hopefully that made sense. So really, this is more of like a while the current temperature is greater than what's on the stack, then we pop off. And I feel like this while might be something that a lot of people will miss. If it's like kind of like hard to see that, unless you like really run through an example, right? So let's write the code for that. So while our current temperature, sorry, my computer's lagging, is greater than the top of our stack. And the way we can get the top of our stack is we do stack, and then we can do -1, which is like the exact same thing as like length of stack -1. Like these two are the same. It's just like the last element from the end of the list. This will give us the last element, and it's a tuple, and we want to index into the temperature. So it would be 1, right? Because like 0, 1, yes. So while that temperature is greater than that last thing on the stack, we want to pop it off. And when we pop it off, we're returning a tuple, so we can just like put that into I'll say pop temp or pop index, and then pop temp into here, right? So that's us popping it off. So we did that, check. And now we just want to add it to our output list, so we can just append it on. Oh wait, now that I think of it, so we know like the like this one right here means that on this date it takes 1 day until we see an increasing temperature. So since we like pop off the index right here and we know what corresponds with the index in our output array, we can do output pop index, right? And then we would do the current index, or like the current date that we're on, minus the popped index, right? And then this assumes that like we have this index in our list, so really our output should be a valid list already. So I'm just gonna make it a list of zeros. That's the length of temperatures, because we know that the output is always gonna be the same as the, like it's gonna be the same length as the temperatures, right? And we know at the very end, like if we don't populate it, it's definitely a zero, because that means that in this temperature list, we never saw a temperature that was greater than the temperature of that day. Hopefully that makes sense. Okay. I think this should be the finished code. Oh wait, there's one last thing actually. So this works. The only time this doesn't work is if there's nothing on the stack, right? So we also want to check that temperature is greater than the last thing on the stack and that the stack is too populated. Because if there's like nothing on the stack and we're trying to index into the last element, there's no last element, I think it's gonna throw an error. And I think this should work hypothetically. Yeah. Okay. Yeah, okay. Hopefully that made sense. And let me know if any part didn't make sense. Oh, thank you for the applause. I love that for myself. Yeah. If any part of this code didn't make sense or it didn't seem like super intuitive or like anything, I can like re-explain. I'm just gonna leave it here then. But yeah. And yeah, we only had 2 problems today, so nice.
Nice.
And we ended on.
Nice. We did. Thank you.
Yeah.
What a Chad you are, Anna.
Yeah, thank you, Tommy.
Thank you, Yunze.
Yep.
Yes, thank you for coming. Or so it would have been me and Tommy, and we would have been sad.
Together.
So sad.
Yeah, each other.